so at the end of the period on Thursday, I flashed this up here to remind you or to let you know that there is no product rule, no quotient rule, nor chain rule for integrals, which would seem like a good thing. However, there is a different process that we'll have to learn about eventually. Now, the biggest problem for you when you start doing this homework is you've been doing derivatives for so long that antiderivatives, you're going to get confused. So remember, in derivatives, you move the exponent down and reduce it by 1. In integrals, you increase the exponent by 1, and you're going to get those two things confused. There's nothing I can do to help you except just tell you that by practicing the homework, you'll eventually get it under control. Here's the bigger problem is that we did derivatives, now we stopped, and now we're going to do integrals for a while, and eventually you get the whole integral thing worked out. But then we're going to bring that all back together, and you're going to be doing integrals and derivatives in separate problems, one after the other. You got to keep those two things straight. Okay, so let's finish up with 4.1, then we'll take a look at some of the problems that you, oh yeah, okay, great, it's important. Then we'll look at some of the problems that you may have had on the homework that you struggled with. So here are our trig values. Okay. This is not a big deal. Don't turn it into a big deal. It's just the opposite. So you know that the derivative of sine is cosine. Therefore, the integral of cosine will be sine. The thing that's going to trip you up is the minus signs. So the derivative of cosine is negative sine. Therefore, the derivative of sine has got to be negative cosine. I always get question. The dx is the thing that tells you what your variable is. 99% of the time for us, it's going to be dx.
So if it was something else, it would be like d theta.
Yeah, then you got a different animal. Then you're going to have theta as your variable. It just tells you which one's the variable. I'm going to show you this dumb thing that I learned, and it's so dumb I'm almost embarrassed to present it to you, but it's so dumb that it might actually work. I always had trouble remembering, was the integral or the antiderivative of sine cosine, or was the antiderivative of sine negative cosine? And so somebody showed me this ridiculously stupid thing. Okay, so if I want to take the integral of the sine of x dx, imagine this thing as a golf club. Bear with me. And here's the golf ball. When you smack the golf ball, it's going to fly to the other side of the equal sign. And in fact, it's going to travel so fast, you're just going to see a blur.
Oh my God. Can you do that one more time?
Now, I will say that I did preface it by saying it's incredibly stupid. But it just might work. The golf ball is the dot on the sign. You smack the golf ball, it flies to the other side, but it's traveling so fast, all you see is just a dash.
Works.
I think it's gonna work because it's so.
Yeah.
Okay. Then these guys,
Oh my God, that is the dumbest thing ever.
I have nothing clever for you to remember those. You just have to remember them. Burn them into your brain. Make flashcards. Has anybody started making flashcards yet? If you haven't started, you may want to. So that eventually when February or March rolls around, you've got this nice little stack of flashcards which will help you get some of this stuff under control. Okay, so we got that, and then like I said, we got the golf thing. Turn this off so it doesn't click every time. Okay. We good?
1 second.
Okay. Aside from remembering what the derivatives, or sorry, the antiderivatives of the trig functions are, you also have to remember the dx, and you have to remember the plus c, because we're still doing indefinite integrals.
I'm good.
Good?
Yep.
Here we go. We would like to find the antiderivative of 8x cubed plus 7 sine x. In other words, we're looking for the antiderivative of 8x cubed plus 7 sine x dx. And just to keep things above board, I'm going to get nitpicky when we first start this. This should be in parentheses because the dx applies to all of it. The same basic rules that we used in derivatives also apply to integrals, so we can break this into separate integrals. and you're not going to do this, but this is the same thing as 8x cubed dx plus the integral of 7 sine x dx, which is the same thing as 8 times the integral of x cubed dx plus 7 times the integral of sine x dx. And again, you're not going to go through that every step, but since we're starting with baby steps here, I wanted to break everything down. All right, Tim, you feeling saucy today?
Maybe.
Maybe. There's no maybe there, Tim. You're either saucy or you're not saucy. What's the antiderivative of x cubed?
1/4 x to the 4.
Are you asking me or telling me?
No, I'm telling you.
You're telling me. Okay, so we're going to leave the 8 out in front, and you said what?
1/4 x to the 4.
Is he right?
Yeah.
Yes, he is. Well done. Let's give it up to Tim.
Nice.
Hannah's good for only one clap. That's it.
Yeah.
Okay, I understand.
I'll give you a pen on that too.
All right, Tyler,
Yeah,
what do you think, buddy?
I'm gonna have to say negative cosine x.
We good? No, we're not.
What about plus c?
What about plus C?
Wheel.
Then clean this thing up a little bit. 2x to the 4th minus 7 cosine x plus c. Well done. These parentheses are important because it's not 7 minus cosine, it's 7 times the opposite of cosine of x. In your brain, be honest, did you use the golf thing here?
No.
You did, didn't you?
I looked back at the other.
I guess I saw that little sparkle in your eye. You're like, oh yeah. Anyways, let's move on. Any problems here?
You're not really good at
No.
Good.
Could be like a hockey puck.
Yeah, he's probably a hockey.
I'm better at circle, not
It could be a hockey puck too. Is that what you said?
Yeah.
Yeah.
Okay, it could be. Yep. Is that what we got?
Yeah.
Excellent.
I mean, club and club.
It's just a double-sided golf ball.
Hold on, a double-sided golf ball?
The symbol, no, the club. The symbol of it looks like a. Okay.
It's for a lefty or
Double-sided
righty.
golf club is what he said. Club, not ball.
That could totally change the whole sport of golf. If you had
It's
to
like twirl
have,
it like a certain amount of
like your
times.
iron was on one side and your wood was on the other, so you have like a driver with a big fat head on it, and the other side is like a 9 iron. You have to swing around the.
Your bag would get so jammed.
You just made golf.
You'd have to totally redesign the structure of a bag.
That's true. Coach should get on this.
Let's talk. I'll take a percentage for the idea. You guys can do all the manufacturing,
This was my idea.
and you can use my face.
Oh my god.
Thousands of golf courses all over the country. All right. So here's another example. Take the original integral, rewrite it. So you might want to clean it up a little bit. You'll see how that applies here. Then integrate it. Integrate, same thing as finding the antiderivative. It's that process that you go through, and then simplify it. Okay, find the antiderivative of that bad boy. When you get done, check with your neighbor to see if he or she has the correct answer, or at least if he or she is in agreement with you. If not, feel free to fight to the death. Universal gravitation.
Struggling, that's what
What'd you do?
Five.
Yeah.
Well, the 5 just stays there.
Right.
So you add 5, just like, so you have 3.
Simple math.
Oh, is it just one?
What did you get?
So you're done now. Decimal calculus stops with differentiation and you don't want to go back.
Minus 1/4.
I understand.
Or you could put, well, x to the negative 4/3.
No, I said the
What
fourth.
is it?
Have
Wait, what was the last?
No, negative 1/4.
Oh, I just put, oh
X to
yeah.
the negative 4.
So it'd just be 1/4x to the negative. That's what
Yeah, 1/4 x.
4x.
Yeah, push it to the second one.
There's a lot of guts to bring that.
I just brought it to the top.
You were there?
Freezing my butt off.
Alright, 12 fifths x to the 5th, this is what you got to. Minus 15 fourths x to the 4/3. Minus 1/4 x to the negative.
Wouldn't it just be 1/4x?
Anybody got it yet?
Negative 20.
Step.
You think, Betty? Catch him. Don't break my pen.
Broken it!
You know how to work that? I'll talk you through it. Take the cap off.
Charger.
And then click on the top square on the strip. There you go. Then pick a color.
Blue.
Shh. No peer pressure.
Good.
And then knock yourself out.
Alright, I can do it. Do it
Would you like a clear screen?
No, I can do it here.
Okay, beautiful.
It's like lagging.
So it's the board's fault you couldn't draw this quickly, Mark. Excuse.
It's not funny at all. Wait, I want you to wrote the 12x.
Maggie.
Okay, so she started with, keep working, we'll talk around here. She started with the original integral, she rewrote it into simplistic terms, so 12x to the 4th is going to change. The cubic root of x is 1/3, raised to the 1/3 power. I think that's what you said, right?
Yeah.
Okay, and then 1/x to the 5th is x to the negative 5th.
I feel like that's the only thing I've ever contributed to this class, like that's really black. No, it's saying plus C. Being red.
It'll get you far in life.
Maggie, stop. You're gonna mess up. What if the name of the project is we get plus C? It works.
Hey, Bill, bring in the plus C guy.
What?
Our company is called company with an extra C in the front.
Yeah, but they had all their letterhead printed wrong, so it all says company on it, so every time they want to deal with it, they gotta bring you in. Bring in the C guy.
At York against York.
Best job ever, you just walk
No,
into
I didn't
a
want to
boardroom meeting, and just like, leave, everyone's like applauding.
Then you walk out like a
Yeah,
rock star.
there's
Thank you.
no
Thank you.
There's like five there, you
High five the executives
Yeah.
on the way out. All right, let's give it up. Where's my pen?
I don't have to look it over.
Okay, so for those of you, some of you that are struggling, she made a couple jumps here that we might need to talk about. The first one, pretty easy, yes. Raise the exponent by 1, so it's 5, and you multiply by the reciprocal, so she multiplied by 1/5. Great. Can't simplify 12/5, leave it like that, that's fine. This one, that's a big jump. You want to explain how you got that?
So you're adding like 1 to the exponent, so it'll be 4/3, 3/3 plus 1/3, so that's 4/3, and then you multiply by the reciprocal of 4/3, which is 3/4. So 5 times 3/4 is 15/4.
Good. And then the second one, this is a common mistake. -5 plus 1 is -4, not -6. Okay, and that happens a lot. So raise it by 1 gives you -4, and again, if you raise it you take the new exponent and you multiply by the reciprocal. So the reciprocal of -4 is -1/4. And then the same rules apply. We don't want fractions within fractions, and we don't want negative exponents. So she moved the x to the 4th to the bottom to get that, and she remembered her plus c, because Grant just kept yelling it over and over. Okay. We good? Any questions on that? Awesome.
Ow.
Okay, we're done.
What is cheese?
3.14.
The derivative of milk is cheese. The integral of milk is cow,
Got it.
right? So the second derivative of cow would be cheese. And then that's just pi.
What's the derivative of
Where's yogurt?
milk?
What's the derivative of milk?
No, what's the derivative of milk? I mean, cow.
The derivative of cow would be milk. Because if the integral of milk is cow, then the derivative of cow would be milk.
What's the derivative of?
But
Of cheese?
if the derivative of c is m,
I like the tribal pocket.
Yeah.
It's really hipster.
Yeah, it's a movie.